Good morning. So we are starting the unit 1 of VLS and Design Technology subject. First chapter name is HDL. So in this HDL, what is HDL? Hardware description language. In the previous lecture, we have studied what? Styles of modeling. Styles of modeling in VHDL. Okay. In that one, first one was data flow modeling. Second one, behavior. Third one is structural. And fourth one is mixed. These are the different styles of modeling in VHDL. So what we have covered in previous lecture, what we have covered is data flow modeling in the styles of VHDL. Data flow modeling, we have studied about what? If, case, all the statements, when, else, select, these all are we have studied the what? Data flow modeling. Different operators we have studied. So we will come towards next one, that is behavioral modeling. See, data flow modeling is used for what? Concurrent statements. Concurrent means what? At a time, now on the concurrent statement means what? At a time, the program, the data will be one by one, and data will be executed. But in the sequential, one by one, concurrent at a time. So first, next one is what? Behavioral modeling. It is also called as what? Sequential modeling. So now we completed this one. Next is the second type we are studying now. Second style of what? VHDL modeling. So second one is behavioral modeling that we will study in this lecture. In the behavioral modeling, it is also called as sequential. It is also called as sequential. There are four statements. There are four statements in what? Behavioral modeling. First one is if, case, wait, and loop. See, these are the four statements in behavioral modeling. If, case, wait, and the loop. If means, already I have explained while explaining the data flow modeling. In that one, if means there is a condition. So it is a condition. If it is satisfied, then it is okay. Otherwise, it will go to the otherwise. That is otherwise. OTHRWISE. While explaining yesterday, I explained about what? Taking the multiplexer example, I explained you about data flow modeling. In that one, while explaining when, wait, we have studied all these things. So first one is if. If means it will come in condition. If that condition is satisfied, then the output will be okay. So that is the first one. What we are studying? We are studying in what? Behavioral modeling. Next one is what? Case. Case means, for example, while explaining multiplexer yesterday, what I showed you that there are 4 inputs, 2 select lines, and 1 output. Okay. So here there are 2 select lines. Means what? We are having different cases. How many cases? For example, for S0 and S1, 0, 0, 0, 1, 1, 0, and 1, 1. These are the different cases. So it will check for different cases here. So it is called as case. Means you are having different options. You are having different selection lines. Means multiplexing you are having selection line. So that example I am taking to explain you the case. So here we are having what? 4 cases. If it is 0, 0, then it may be A. Next will be B. Let's see. Otherwise, it is D. So if it is 0, 0, it means if it came here. This is the case 1, case 2, case 3, case 4. It is come as case here. Next one is wait. What is wait? Wait is same as if only. Means what? For example, it is same as if. How means? See, I am executing in a program. It will start when the clock is, example I am telling you, 60 seconds. If it counts 60 seconds, then only it will start with the execution. Okay, for example. So it will wait till 60 seconds. When A is equal to 59, then it will not execute. When A becomes 60, then it will execute. Means it will wait till it is 60. Means if A is equal to 60, if A is equal to 60, then it will execute. Means what? If A is 59, then it will not execute. Means it will wait. Okay. So automatically it will come as if. So only I told you that wait is same as that of the if. So then what is the loop? What is the loop? See, if A is less than 60, for example, when I is equal to 0, I is less than 60, it will go, means what? Here, I will increase from 0 to 1, 2, 3 till 60. I'm telling about now loop. So did you understand this if case? Where next one is what? Loop. In the loop, what will happen? It will continue, this loop will continue. For example, y is equal to a plus b is there. It will do this design, it will do this process. When a is from 0 to 60, it will do. Means if a is equal to 1, b will be constant. For example, I am telling you, this is an example. What is the example here is y is equal to, if y is equal to a plus b, then a will be increasing from 0 to 60. Less than 60 means will be 59 only. So here b is constant. Means what? A is equal to 1 plus 1. It will be 2. Answer will be. Next we will go to the next step. Then A is equal to 2, 3, 4, 5. Till 59 it will count. Okay. It will do 1, 2, 3. Just loop. This loop will continue till it is 59. When it comes 60, it will execute the loop. That is called as loop. So there are 4 sequential statements in the behavioral model. 4 statements in the sequential statement, or it may call it as a behavioral modeling. In the textbook they have given actually and, but behavioral modeling is nothing but what? Sequential modeling. Sequential statements are there. There are 4 cases: if, case, wait, and the loop. 4 statements are there. These 4 statements are there in where? In the process. While explaining the introduction lecture only, I explained about. We are having process. In the process, in the function, and the procedure, we are using these 4 statements of the behavioral model. These are the 4 statements which we are using in procedure, function, and the process. This is about the behavioral model introduction. Next, we will start with the process, then the signals and the variables, and the constant which will be afterwards. So first, it is just a summary of the behavioral modeling. Next, we will start with the process. What is process? How it will work? That we will study now. First one is what? Process. See this process, I told you there are four statements. If, wait, case and the loop. What are the four statements? If, case, wait and the loop. These are the four statements which are there in the behavioral model. In the behavioral model, what you are having? Process, function and the procedure. So now first we are studying what? Process. In the process you are having four statements that only repeating and if, wait, loop and the case. These are the four statements. So there is a syntax for the process. This process is what? It is a sequential execution part of the VHDL. Process is a sequential execution part of the VHDL. Means what? In the process, the execution will be sequentially. Okay. So I will tell you the syntax now. If you know the syntax, then only you can write the program. Syntax. In the syntax, madam, so now I will explain you syntax of the process. So this is in the behavioral modeling. Okay. Syntax for process. Syntax, label, process, sensitivity list. Variable name type, range, initial value, begin, sequential code, and the process, label. See, it is a syntax for the process. So in this contains label, process, sensitivity list, variable name type, then that's range, variable range. That is initial value. I told you just now while explaining the example. If it is from 0 to 60, then that is the range. And starting with the initial value. Next, begin sequential code, because it is behavior modeling, it will come as a sequential code only. Next, end of the process. See, this is the syntax for what? Process in the behavioral modeling. It contains label, then the process name here is variable name, type and its range and its initial value, then begin with the sequential code. Next is the end of the process. Here label is what? Optional. It is not compulsory that you have to write the label. And next, in the variable is, listen carefully, here this variable is optional. You may write or you may not write. It is optional. Second thing is variable is declared in the declarative part before the begin. Variable is there now that you should declare before the begin. This is the second important one. First one is label is optional. Second thing is that variable is declared in the which part? Declarative part, which is present before the begin. Means if some variables are there while writing the program, if there are variables, then you have to declare that before the begin. And next that it is you have to write that code, sequential code. It is after begin you have to what write? What will write? Code. Then it is the end of the process. It is the syntax for what? Process. So now I will explain you with an example. I will explain with an example of what? Process. How it will work? Process is in come under what? Behavioral modeling, where it is sequential. Sequence means what? One by one. I will take one example and I will explain about the process. So taking the D flip-flop as the example for the process. So what is D flip-flop? Just studied in what? The previous lecture I talked about the D flip-flop. Flip-flop is a single memory element. It contains the input as the D, single input, and a clock and a reset, Q and Q bar. This is the D flip-flop. D input, clock will be there, set reset will be there, Q and the Q bar are the outputs. This is the D flip-flop. I will explain. How I explained while explaining the data flow modeling is that I have taken MUX multiplexer as an example. Now I am taking D flip-flop as an example to explain what? Behavioral modeling. In that process I am telling you. So what is the truth table for this D flip-flop? It is simple. Clock, input and the output. It is not there in the textbook. You are already studying what? But it shared on the subject. When the clock is low, when the clock is high. Okay. When the input is 0 or 1, the output will be, there are two outputs. Huh? What are those? Q and the Q bar. Q and the Q bar are the outputs. Inputs are, don't care why clock is low. So there is nothing meaning here. Because if clock is low, then there is no, if you are giving input, then there is no, it's because clock is low. So automatically output will be same as the input. So when clock is high, the input is 0. Q will be what? It is 0. And this is the complement of Q, is Q bar is 1. When it is 1, then it is 1, then it will be 0. Okay? When the clock is high, what is D? That will be there in the Q. So it is acts as a memory element. D flip-flop is a memory element. This one I am taking as an example to explain the process. So we'll start with the program. Do you understand this here? What is there means if clock is high, then the input is 0, then the Q will be 0. When the clock is high, when the D is 1, then the Q will be 1. Means when the clock is held, it acts as a memory element. What is there in this? That will be there in the output. You are the complement of this. So that this one, taking this as an example, we will study process. So starting with the program, how to write this? So already I told you that there are three sections in while programming. First one is library, second one is entity, third one is what? Architecture. Library is 2 lines. Entities contains what inputs and the outputs and selection lines. Input and outputs are present in what? Stored in entity. Architecture contains the design. So start with the programming with an example of what? D flip-flop. Library, I typically use standard logic 1164.org. Next one, entity. I told you entity. Entity name is DFF. What is DFF? I am taking entity name as D flip-flop is, and you have to show the what? Inputs and the outputs. For what are the input port and output ports here? D input, clock as the input, reset. I told you set reset. These are the what? Inputs in standard logic. Logic Q as the out standard logic. Any doubt regarding this? See what I'm writing here. I'm taking this as an example. Starting with the library, I have used this library because it contains particular program, function, procedure which is present already in the library that I have taken. Next one is entity. It contains what? Inputs and the outputs. D, clock, reset, these are the input channel logic, and Q is the output channel logic. So next, end of the entity. What is end of the DFF? Any doubt regarding this? It completes 2 sections: library, entity. Start with the architecture. Architecture, behavior. I'm just telling, I'm taking the name as a behavior of the architecture name it is. Architecture, behavior of entity name is what? DFF. is begin, because we are not writing any, we are not declaring any variable. It's directly I started with the begin. Begin process. In this process, what is there? Clock and the reset. Clock and the reset. Next, begin. If reset is equal to 1, then Q is equal to 0. ELS, else if, should not write here E. ELS if, else if CLK clock EVENT event and clock 1 then Q is less than equal to T, end of if End of process, end of behavior. So this is an example of what process in the behavioral modeling where we are using sequential statements with the taking of the D flip-flop. I have written here the program. So now I will explain the program. How it is? It contains three sections: library, entity, and the architecture. Library shows which functions this procedure you are taking from the library, and I have shown here library identically with standard logic. Convert is for all. Entity, the inside the entity, the flip flop is. It contains inputs as D, clock, and the reset. And I am writing here RST as the input, Q as the output. Starting with the what? Now it's the end of the entity. Okay, next one is architecture. Behavioral of what? It is the architecture name of DFF is. Begin. So I have started with what? Process. What I am explaining you? Process. In process, what is that? Sequential. Sequential statements are there. In the process, you are having what? Clock and the reset. I am showing it is in process. Clock and the reset. Begin. If reset is 1, then Q is less than equal to 0. Means what? It is D, it is Q, it is RST means what? It is clock. Okay, listen carefully. If reset is equal to 1, reset, it is not set here, it is reset, it is high. Automatically clock is 0. If reset is 1, signal. If RST is 1, then means it is set reset. Set means started. Reset means it is coming to backward. So if reset is 1, it means what? It is not settled. Reset is active now. Automatically clock is 0. When clock is 0, output is 0. Okay. Else if clock, event and clock is 1. Clock, event and clock is 1 means what? Here the clock is 1. This clock we are showing in terms of what? Event. Keep it in mind. If I am using event, it means there is a clock, that the clock is active. So, event and clock is 1. Then Q is equal to what? D. Means output is what? D. What is D? If D is 0, 1, output is 0, 1. If D is 1, 0, then output is 1. I told you it is actually the memory element. There is no AND, there is no NOR, there is nothing here. Just it acts as a what? It acts as a memory element. Single memory element is D flip flop. So Q is what? D. End of the if here. Where is started? It is started with if. End of the if. End of the process and end of the behavior. First I have ended this if, then the process, then the behavior. Behavior is what? Architecture. So I have ended with the if, process and the architecture. Any doubt regarding this? It is very simple, starting with the library. Next entity. In the architecture, what I am showing? With the process, we are having clock and the reset. Then starting with the if reset is 1 means what? Set is 0. Set is 0 means clock is 0. When clock is 0, then output is 0. When else if the clock is 1, clock I am showing in terms of what? Event. Event and clock is 1, then the what? Answer output is what? Automatically D acts as a memory element. Then end of the three things. So I think you have understood this. It is very simple. So it completes the process in the behavioral model. Okay. In the next section, we study about what? Signals and the variables. Keep it in mind. I have showed today's lecture. I have explained about what? Behavioral model. In the behavioral model, what we have studied? Behavioral is what? It is a sequential. That what you are studying, what you are executing the program is in terms of sequence. Okay. It contains procedures, functions, and the process. Okay, these all are come where in the declarative part. Okay, it contains four statements: if, case, wait, and last one is loop. These are the four statements which we have studied in the behavioral modeling. In the behavioral modeling, we are studying now process. Okay, in the process, there is a syntax starting with the label. Label is here is optional. There is no here so only we did not use any label word here because it is a optional. And all the variables which are declaring, we should declare before the begin. Okay, this is the second thing. Third one is when you are explaining clock, then you have to go start with the if you are using clock, it means it is event. Okay, it may be 0, it may be 1. So I am taking here what? The flip-flop to explain the process. In this one, it contains library, entity, architecture. In architecture, I am taking process. The process contains what? Clock and the reset. Start with the begin. If reset is 1, or automatically set is 0. When set is 0, when set means it is not ready, means clock is 0. When clock is 0, automatically output is 0. That I have shown here. When clock is 1, output acts as a memory, acts as a, that is what is input, that will be output. At the D is what is that? It is a single memory element. If D is a, if clock is 0, output is 0. If clock is 1, which data is there present at D now, that will come to the output. It is just a memory element, it will not process anything. So only if clock is 1, output will be D. If clock is 0, output will be 0. That is there in this. Ending with the if, ending with the process, ending with the architecture. Architecture name is here, it is behavior. So I have written there behavior. Any doubt regarding this? This completes today's lecture with the process. So in the next lecture, we will study about what? Signals and variables. If you are having any doubts, ask me and write the notes which I have given. I will give always in your group.